All right, let's begin. Welcome, everyone. This is a free live webinar on biohacking your environment. As you might imagine, it's going to touch upon everything. We're going to touch upon so many aspects. You're going to learn a lot. We're going to learn how to grow a lot. It's going to be fun. So thank you all for being here and participating wherever you are. All right. So did you know that horizontal gene transfer is more significant than evolution in terms of adaptation? Did you guys know that? And the reason, let's get into why. So what is horizontal gene transfer, HGT? Well, it's this incredible process by which microbes, they've seen everything in the microbiological world is transferring genetic material. And so they're consuming it. They are embodying it from the digestion, and we know that when we eat food, we actually modulate our genes. That's what epigenetics, the very tiny molecules in food, all of that, right? The microbial release in our digestion of those things, all of that has to do with horizontal gene transfer as well. But there's also conjugation, where they're literally they're not like reproductively having relations, but they're conjugating. They make little microphalluses and they exchange DNA at an incredibly rapid rate. And so they look like tiny little vibrating bunny rabbits, except that they're cells. They're unicellular beings. And that they're exchanging DNA and information about their environment. So it's actually critically important when we see that or when we don't see that under the microscope. And then viruses. Viruses are happening all the time. They're in our bodies. They're in our food. They're all over all the surfaces of things. And most of the time, they're at such a low volume of quantity. They have low counts. So they're more informational. And our body handles them and processes them as information about the environment. It's when things get to a hyper concentration that they, when they're dominant in many cases, that they cause problems. So more people would like to get in. Let me let them in. All right. So why is this relevant, Matt? I thought we were here to talk about biohacking or soil or permaculture or something. And now you're talking about horizontal gene transfer. This seems a little like zoomed in. You've been spending too much time on the microscope. Well, and you're like, I thought this was only proven with E. coli. E. coli being, well, let's think about that for a second. E. coli is the fundamental feedback loop for all life on Earth. Did you know that? Do you know that 20 to 40% of all the samples I take are E. coli? Everything has E. coli on it. Most of the species of E. coli are commensal, or they're endophytic, or they're part of our digestion, which means they're endosymbiotic to us and all animals. Much different picture than like there's like a handful, there's millions of species, there's a handful of pathogens, and they get all the play. They get all the people talk about them all the time. They get all the airwaves, and meanwhile, the rest of the world is dominated by this feedback loop. So what does that mean for us? Well, there's millions of species, only a handful are pathogens. They are plant endophytes. They're found in all animal digestion. There are 18 to 20% of all the compost and soil samples that I've DNA tested, but those are specifically mostly healthy samples. As for I have examples in the literature where it's about 40%, about 50%, and that's the thing. Once again, we've circled back already to the fact that it's concentration. So balance, ratio, concentration. These things are the way that we actually measure things. Just throwing a number around, if we don't have a context, can totally fool us. 20 to 40% of soil is unclassified DNA. DNA can take up to a million years to decompose in nature. Horizontal gene transfer means that E. coli sources new genes from its environment constantly. So it's, going and consuming and having relations with everything around it. And so it's constantly exchanging information in DNA. There's only a certain number of slots in E. coli. if you go and check out the world, because I check out everything, and so I'm because I want to know what they're up to. If you look at the genetic engineering world, they call E. coli the universal chassis, because it's constantly removing and taking on genes that has these like slots, like cartridges, and so they can like make it into almost anything. It's really wild, but that's the thing, is what we've realized with DNA is that there's so much lateral expression that the horizontal DNA reproductive generation after generation expression doesn't really hold up to what is happening in reality. Things are reacting in such a way that they're sharing genetic material. There's jumping genes, there's horizontal gene transfer, there's all these things happening in real time. And so that's why you have like these lookalikes under the microscope, lookalikes in, the most vibrant and predator rich areas of the world. You have like moths that look like snakes and caterpillars that look like sticks and everything above, and so this is why E. coli is in your gut, because E. coli was in the plants to begin with. Before animals showed up, E. coli was doing its thing inside the plants. And we can see other endophytes very clearly with some techniques I'm going to show you here in a second. Do you see the pith on the right, on the left, I should say? Do you see the xylem and phloem around that? That's what this actually looks like. Do you see how on one side it's brighter than the other? That light is on one side. That's the phloem, not the xylem. So the endophytes are in the phloem. They're flowing in the phloem, and you can see them on the outside and not the inside of those circles. This is how we make things real, by actually looking. If we don't look, it's not real. If we don't look, how can we develop our understanding? This is what I've been working on the past several years. So this is a corn seedling root. This is inoculated with a popular inoculant. And you can see the mycorrhizal and mycorrhizal associations beginning. This is obviously not extremely mature, because you would have a lot more expression in terms of spores. So why is this important? Because we are constantly absorbing new information about the world around us and adapting at a microbiological level. That has a direct influence over our genetic expression. So everything around us, the environment. So if we want to biohack, we got to biohack our environment. You see what I'm getting at? The food molecules and the nutrients influence and trigger epigenetic expression. So the microbes digest our food for us in our gut. And your soils and your plants are doing the same thing. They're all relying upon microbes to perform the cycles of their nutrient cycling. Or, we call it digestion, but it's really nutrient cycling that we're doing internally. So are your plants and soils inoculated with the right biology for your particular needs? Do you know? How do you know? But before we go any further, who am I? I'm Matt Powers. I was a ski racer in New England that became a professional bass player. I play with people like this. That's my band, The Cringe, that I was in for 7 years in New York City. Saturday Night Live's drummer was our drummer. The editor for Guitar Player magazine is on the far right. And Rachel Ray's husband is the guy in the green shirt. That's ZZ Top's Billy Gibbons. We had met that day, and later that day we jammed on stage. And it was at this time where I was a touring musician, a session musician, a studio musician in New York, and traveling all over North America at that point. I met my wife. And very shortly after we got married. I knew she was my wife 3 days into knowing her, actually. And what happened essentially was my wife very quickly got cancer. And so she lost her thyroid when James was just over 1 year old. Our son is now 16 going on 17. It's a very long time ago. And if you know anything about that, you know how that can be like an extreme challenge for some people. So I had to change course. I had to become Mr. Powers. So I stopped doing the touring and recording and professional musician work like thing. And I just became an educator. Yeah, I just became an educator. And so what initially happened was, and we had our other son, which was a miracle because at that point they didn't even know without a thyroid if you could have another child. So I fell in love with teaching, but at first I didn't. I didn't like public school. I had hated that whole experience. I felt like teachers were just like just small dictators, and so like I didn't like it. And so the idea of me participating in that kind of oppressive activity really bothered me. But then as I was subbing, I realized these kids really desperately needed someone there on their side. And so I started teaching English. I was hired by this special school that allowed me to get all crazy and silly. I started teaching organic gardening and seed saving along with English. They gave me a garden. I had a music class. I had an entire like studio. It was wild. It was an incredible, it was Minarets High in Madera County in California. It was an incredible charter school that it was all laptop based, and because they didn't have any curriculum, I had to create all the curriculum from scratch. So I had incredible amounts of freedom, but I also had to create individual preps for all 150 kids. So it's pressure, but you had to I had to figure this out, and most people couldn't figure it out, and so they're doing traditional teaching in that format and struggling. And because I was this first student teacher that school ever had, I was given a lot of attention, and I also did my master's degree as I was being student taught all at the same time. And I fell in love with teaching. I realized I could do a lot of good by figuring out how to fix the educational system. And one of those things is connecting people to nature. And the best way to do that is through getting them to taste it. And when you do that, they can't deny it. And so I started feeding my kids and growing things that were impossible. And I fell in love with permaculture because it was the only way with the soils that I had, where it was like 140 degrees Fahrenheit in the soils in summer, to be able to actually grow food at any level. And this is the kind of level I was able to grow at in those soils. This is an area that was not even watered, throw sown seeds on the ground 3 months into that heat. And so I wrote a book for curriculum for K through 12, the first permaculture book, and it took off, went all around the world. It got translated in all these different languages. I started working with people all over the world, started speaking and traveling, started working with different organizations to help them get their food forests at another level. And then in that process, I became a citizen scientist, learning about how to use microscopes, how to DNA test, everything under the sun that pertains to permaculture. I've had to learn, and my family's grown up in the interim. We still have our health challenges, as I alluded to earlier, but we're still here. We're still fighting, and we're still loving being in harmony with the world around us. So I've written over 24 different books. I'm currently working on regenerative soil microscopy. I am 98% done with the final edit. So close. And I've done over a dozen online courses. I love it. I've become an educator in so many different ways. I've gotten to teach so many different courses and curriculums and create so many different workbooks and teachers guides for other people to teach in colleges and high schools and schools and homeschools all over the world. And really, I've been working on a bridge to the regenerative future, in essence. We don't have the educational materials to train people to be able to start the businesses, to be able to run those businesses and be able to have the skills to be employees of those businesses for the regenerative economy. And I say regenerative, it's not sustainable. It's not the political terminology that they're running around with. No, this is stuff that we can do. This is what we talk about our future every single year with regenerative entrepreneurs that literally are running businesses that are changing the world, employing people, making good money, and as well, making regenerative soil, making regenerative orchards and food forests and farms and community services and all of the above. Everyone's biohacking journey. So if you are like me and have been worried about health for, almost 20 years, in such a way that it, sits on your mind all day and all night at times, and could depress you because it's attacking your loved ones, you might have gone through all the different possible avenues, right? Notice how these are all kind of focused inwardly, right? They're all like physical, inward, and we alluded to the environment's effect before. And this is subtractive and additive in different ways, right? Lowering exposures in our foods and homes. I know it's last on the list. Why am I going to the bottom? But just bear with me. Everyone's taking away. They're like, oh, I don't want lead. Oh, I don't want this. And then they're like, but what do you want? It's like, let's sterilize everything. Okay, that's good for like 5 minutes. And then it's whatever is most aggressive that can fill that gap when everything calms down, fills it. Does that sound like a good policy? No. So we need to be thinking how to be regenerative, additive, but cyclical, so that we build and we have health that is resilient in the landscape and the soil and our bodies, all of the above. And so diet obviously is something that was the linchpin early on for us and my family, figuring things out. I got the mental and physical side of it much later on. At first it was just eating right, and then I started doing yoga, and it's like Diet Coke of yoga. It's diet soda, I should say, because I don't drink any of those kind of things. Coca-Cola, Pepsi, anyway. But like I don't do like crazy, wild yoga. I know people out there who are amazing at yoga. You could just kick my butt. But for me, I have a routine. I do it every day. My body loves it. I need it. And then mental, I started doing meditation about 8 years ago, and that became an ingredient, a must-have ingredient. Supplements. I take a lot of supplements, like a lot of vitamin C, a lot of vitamin Bs. Vitamin Bs are biological vitamins. They deal with cellular metabolisms. That's why they're so important. Anyway, I do all these things. I've done, saunas. I've done hyperbaric oxygen chamber treatments. I've done a bunch of different things. I used to do detoxes. Remember when we used to do all those different things back in the day. I'm looking forward with fear to doing cold plunges, because I tend to just be tight in general. And so I'm like afraid I'm just going to be so tight, I'm going to snap or something, but I'm still going to do it. James is like, my oldest son is like, give me the cold, I need it. And so we're going to figure that out. But this is something we do in our family. This is something that we are all about, priming our energy and our bodies and our minds to be at peak states for extended periods of time so that we can perform at a high level. And I think that's what we all want. I think many of us deal with feeling is that possible for us, right? I think the biohacking movement, Dave Asprey, a lot of these people have shown what's possible for so many of us. And it's wild and incredible. So this is pretty typical though, right? But is there more? Well, that's what I want to talk to you today about, because you already heard about all of those other things from other people who are experts like Dave Asprey and yada yada yada. But I have something to tell you and to share about blue zones that I don't think anyone's ever thought about before. But given the realities around what we're going to talk about today, must be present and affecting to varying degrees. So let's dig into it. There's a lot more here. Remember the blue zones? People are living the longest in the blue zones. George Harrison's wisdom. You know, George Harrison from the Beatles, he has that song where he's talking about the further one travels, the less one knows. Arrive without traveling, all that, right? When I took Jeff Lawton's course years and years ago, he said, you know, the longest living, healthiest people are the people who don't travel. Of course, my wife is like she wants to travel all day, all night. Like she grew up, she moved 23 times before she was 12. We're completely opposite. I am a hermit homebody. That's how I create all the things that I do, right? That's how I grow all the things I grow. And so there's something to that. Not just that we compound our efforts when we hold still, we there's something, and you know, the meditative, I think George was talking about that meditatively, but I think there's something more to it. There's a real feedback loop here, an actual feedback loop that comes soil to plant to animal to compost and then to soil again. It's this loop that dominates these local everything, the local food, fiber, medicine, all the local economies that they support. All of them are biologically overlapping and interacting in a predictable fashion. And it's also person to person. They're in these blue zones. They're going to the farmer's market. They're talking to the same people every week. They're going to the butcher. The same person is working on cutting their meat. The same person is wrapping up their produce or picking it. Predictability for microbes allows them to spend less energy on adaptation. And I mean adaptation to stressors, because they already have the processes inherent in them to perform at a higher level. But we need to take away the stressors in order for those to be fully expressed microbially. So I mean, you've definitely heard by now, you know, it's like you can cover your face with all sorts of different things, but microbes are so small, viruses are so small that they pass through all those things. And there's a lot to this, because you actually can't see those things without electron microscope for the most part. And so unless it's a giant virus, you can't see those things. So there's a lot of shenanigans going on, and we are missing the actual paradigm for the way humans adapt, the way communities draw closer. There's a biological and microbial level to that. And I believe we need it. There's a reason why within weeks our hearts align their beats in a chorus at a church or a choir or a singing troupe. Your hearts begin to align in the way they beat. And as we know from the lockdowns, they've proven that, you know, when you're singing, you're broadcasting microbes out into the world. But what you're actually broadcasting is the environmental reaction to the world, out into the world. And on a community level, that's essentially quorum sensing. And when we are in harmony after that several weeks, there's a biological and microbial layer to that. And I know there's heart math and heart coherence, and how would they not be stacked in their function? You know what I mean? Because all of the relationships that matter, the majority of them are electrical, not pH. They're redox, reduction and oxidation. And yes, the oxidation is the loss of energy, and it's measured in millivolts. It's crazy, right? Yeah. The future of health is built around these things. So microbes carry these these messages to us, and these modulating informational packages. EM, effective microbes, is a trademark term, but remember, it's trademarked because they're selling this consortium with that name. It protects the name. And I'm friends with Terra Organics and all those folks. And I love EM. They've done incredible work for the world. EM1 it primarily is lactobacillus. It's lab. We can make this with rice wash water. We can make this a bunch of different ways. We can make this with kefir. See how it's active ingredients. It's guaranteed to have lab, nothing else. There's an argument that it has what the EM1 Pro has, which is the Rhizophagy palustris, which is the purple non-sulfur bacteria, as well as the streptomyces, as well as the yeast, the cerevisiae yeast. Those aren't guaranteed on this. It's important to remember that. I've tested this EM1, this bottle I'm holding, and it didn't have any Rhizophagy palustris. So we have, well, all right, it had one count. And when you're looking at 11,000 counts, one count is not significant enough to be like, it's in there, right? Especially when you look at just dirt and it's in there at a higher count. So anything else would have higher counts, right? So it's important to recognize these things. But EM, what is this? Well, it's supposed to be Saccharomyces cerevisiae, lactobacillus species, Rhizophagy palustris, streptomyces, and E. coli. And they won't list the E. coli, but it's there and it's meant to be there. So this is what it looks like at 1000x with the epifluorescence lens. You can see the phosphorescence there, the autofluorescence of the phosphorus presence in the yeast cells. They're endophytes. All these guys, they're endophytes. They're messengers of the feedback loop. So they're breaking down the compost because EM's used in composting, and it's actually present in all good compost. And so it's essentially like the essence of compost. And I know this is true despite people saying they're anaerobic and blah, 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 they're bad and all that stuff. I DNA sequence things. That's what I do. And so I know, like, the best Dr. Elaine Ingham compost has EM in it. They're facultative anaerobes, not anaerobes. So they're non-pathogenic. Important to know these things. And so they're actually messengers. So they're inside the plants, they're inside decomposition, they're inside the soil. And so they're these messengers of the environment itself. And we need these microbes to digest our food, and so do our plants. Let me say that again. We need microbes to digest our food, and so do plants. There's a debate about whether the microbes in EM are ideal for digestion. EM Pro is USDA and CCOF approved for digestion. So, but the evidence about Rhizophagy palustris, I know it's non-toxic, non-hazardous, but again, there's scant evidence. But anyway, put a pin in that. If you know me, you know that I'm always going to bring up the caveats, the exceptions, and show the whole context, because that's where it's interesting to me. I think that there's a lot of confusion out there where people are just cherry picking and saying generalizations, and it's creating a lot of problems when it comes to actual application. So we need to eat plants and animals from living soil. because that way they're in feedback loop with their environment and they're in harmony with their environment. And when animals are in harmony with their environment, they don't have stressors in the same way. And when then they can put on more nutrition, they can be healthier, plants and animals, us included. So living soil all the way up, no matter what your diet, right, is incredibly important. And before you're like, well, the oceans, I eat fish, pescatarian. The oceans have soils too. And these ideas and processes actually play out there too, because plants are plants, animals are animals. The plant health pyramid, John Kempf, excellent lens to look through to better understand these things. Keep in mind that he generalizes, calling it vigorous biology. We need vigorous biology, but that doesn't tell you who. And that's been my mission. Elaine Ingham will talk about the bacteria and fungi, the generalized ratios. Again, is it a saprophyte, mycorrhizal? Is it pathogenic? All of the above. It's really important to like suss that out and keep those things separated, because it will create a lot of confusion when it comes to actual practice. And yes, I know John Kemp has his own blend of microbes, so he does know microbes. He's read my book. He's one of the editors for my book. He knows the microbes. He sells the microbes, right? That's not what I do. I'm a former high school teacher. I want you to have the tools to be able to go out and create new things and express and fully explore. And I'm really keen on that transformation. I taught sophomores, so it was all about preparing for junior year, the big year, you know. So aren't we kind of culturally in that moment? We're in the middle of having to have a big year. So this is really important. This shows us that we need balanced chemistry, and then we need really particular vigorous biology. And then we have plant secondary metabolite synthesis increasing and expressing better taste, better smell, better looking colors. And then there's more the lipid synthesis. So there's more oils and fats. And this is all driven by microbiology. Even the balanced chemistry, that's the biology is releasing all of those nutrients. It's just, and I know there's weathering and stuff, but that's not primary. The plants and animals evolve with this biology in place. It is their externalized digestion. We must inoculate our soils and foods. Have you guys heard of IMOs? These things are catching fire. Someone just wrote me today saying that they had dinner with the Cho family, Master Cho and his family, and they're like eager to meet me and talk with me. They know of my work. I've been sharing their work, that's for sure. And I know they're good friends with Chris Trump, so maybe, I don't know, maybe it came up, but I didn't expect me to be on the radar like that. But they want to meet and get to know me. So it's awesome, very nice. Indigenous microorganisms are fascinating to me. You won't get a good answer of what it is from most people unless they probably talk to me first. And so I've been doing investigations and examinations and case studies on IMOs. And if you've got samples, you know, I'll take them. There's just a few different things. It would be best if you actually took the picture so it was fresher. And that's also the truth around everything. That's why I'm all about empowering people and giving them the skills, because we need things to be fresh. We need things to be on site. We need things to be repetitive. We need things not to be, sorry, John, in a pyramidic structure. We need things to be lateral, community-based, communicative. And so this is most likely Zygomicota, most likely either Rhizopus or Mucor. Well, this one's Rhizopus, the other one's Mucor, most likely. And so there's indigenous bacteria inside them. Those fungi that I just listed, that are the white fluffy, they're rice mold. Like straight up, they're just rice mold. But the thing about rice mold, they're just like us, and fungi is just like us in that they have bacteria inside them helping them digest. Do you guys see all that? The dun, 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 dun. Yeah, so that's all bacteria in there. And if they're full of bacteria, we know they're non-pathogenic because they've got everything they need. Let me zoom back out. So what if our foods were carriers for the microbes we needed? So all those all that bacteria in there, that is most likely a good proportion indigenous microorganisms, and at least some portion of saprophyte and indigenous bacteria from the rice itself, like lactic acid, like lactobacillus, will be in there. Like you actually can't. Rice, when you heat it up, you're activating the lab. You're not deactivating it. So lab is getting activated by this process. So we really need to understand that this is a portion of IMOs, and then a portion of endophytic, and then saprophytic, because they're both there. There's an overlap of saprophytes that are endophytes that go into the plant, and then when the plant is dying, decomposing, they break down the plant, and then they cycle. So they're a constant companion. And this is why people are like, oh, my plant, they got killed by this fungi. And then they're like, oh my gosh, this fungi is in my other plants. And it's like, that might be an endophyte. And the management of that soil or that grow or that green or whatever wasn't matching that plant's needs. And it's a nest. So this is really important for management to understand. And then what about energetically? Well, remember I mentioned oxidation and reduction. Think about grounding for a second. Remember, you guys know grounding, right? So why does it work? I'm going to make sure that, all right, we're working well over here. So why does this work? Well, do you guys know how an old battery no longer holds its charge? It's because like one side of the battery has one thing and the other side has another thing. And then when they like combine, there's no longer like a difference between them. So salt collects on like the metal part, and you can shock that battery and remove all the salts. You know what I'm talking about? Okay, the differential is gone. And so everything in life is actually about differentials. In life and nature and the systems in our bodies and the soil and the air and like everything's about differentials. The sky is positively charged. Do you guys know this? The earth is negatively charged. That's why we get grounding, and grounding has been proven medically. It's not woo-woo at all. Doctors are like, oh, your blood pressure literally just drops the second you put your feet on the earth. I've interviewed Iowa doctors. Okay. This is not like, Berkeley, California, where they're trying things out. This is Iowa, and they're doing food forests for medical centers to help people recover faster and the medications to be more effective, so that they save money on medication. They save money on inpatient time. And this is real, undeniably real. But there's a problem here that it exposes that no one is talking about. It's oxygen rich, supposedly oxygen rich. Oxygen's been in decline all over the world, right? The soil's supposed to be carbon rich. Let's talk about that. When they're tilling all over the world all the time, in ancient Rome, they tilled sometimes 6 to 12 times a year. That's why all the soil in Italy went into the sea, into the Mediterranean. The carbons oxidize, make CO2, and the oxygen is brought down to bond with the carbon, and it physically disappears. We physically are making the world less oxygen rich, by combining the oxygen with the carbon in the soil. And oxides in the soil are the things that are unavailable and locked up. You guys know the Fenton reaction? This is how soils lose their dark color. You've seen that bare patch that's been sitting in the sun and it's lighter. It's been zapped. It's dead. This is why. And that's higher EH, so that's less energy. And it's higher pH, so it's more alkaline. So so the CO2 is gassing off the carbon and the nitrous oxide is gassing off your nitrogen. Not good. And then they leave it bare to let it sink in, right? It's like, what are they thinking? And then they're like, let's do it for all of Nebraska and Iowa. Really? Their pesticides and fungicides and insecticides also kill the soil life and destroy the soil organic matter. Remember, nematodes are just tiny worms. Remember, microarthropods are just tiny insects. And soil structure is about a third fungal, globally speaking. Think about that. When I'm under the microscope, I'm seeing these long fungal strands holding together chunks of organic matter. This right here is terrible soil that I'm looking at. Well, it's actually compost, which is, I mean, it looks like soil because there's so little organic matter in it, but it's this local Texas thing. And it's just all actinobacteria. Terrible. And it's got like a lot of minerals in it. So they're like digging out the pad that they're doing it on and combining it in to make it look like more. Not good. And so they're destroying the soil organic matter just by doing what they're doing. And then they're adding this chemical cocktail on top of it and killing it even further. And that kills the structure, it kills the life, and it kills the fertility, or destroys the fertility, I should say. And so does synthetic nitrogen. The most important thing to understand is even raw char, not biochar, wood char is going to act like this, because as part of nature, nitrogen, oxygen, hydrogen, and carbon all live together inside every organic molecule as the backbone for life. So all life relies upon them in concert. So when you isolate them and make a concentration, they're just lonely. They're just used to living a completely different existence. And so you put them into the wild and they're going to bond with anything that is even remotely close. This is why they're burning things. Synthetic is why they're burning things. They're burning the carbon away. They're burning the organic matter away. They can burn your skin. They can. It's because it's lonely. It's isolated, and it's going to bond with everything you put near it. What's great about biochar is you give it the good things to bond, and then hold for you, and then it holds 3 times as mass in water. It's amazing. So our farmers are draining the soil of energy and life if they're practicing soil management this way. So there are regenerative farmers. John Kemp's been teaching a lot of people at the commercial chemical side. He's been giving them inputs that are slowly weaning them off by following all these principles that I teach and giving them the products to do it all in like sections. You know, it's a business. This is business, right? But for those of us that would like to DIY a natural farm and all, it's like, I just want to be, people have the information, because not only that, we can fix it ourselves. We don't have to wait for, a product to come out. We can create that product. Just like I want to empower my high school students, I want to empower you guys to create things that are new, that are going to change the world. That so many people try to get me to just focus on creating products, loved ones too. And I'm an educator, I'm an empowerer, and I want this information to go out because it's going to change everything. And not only that, no one's doing the educational work. So how can we expect to get to a community level of fluency and to get that like Shakespeare level of understanding? Shakespeare was only Shakespeare because he came out of an environment that was already so fluent in English, and the English language was so alive that there was the multiplicity of meaning, such that in a public forum, he could speak and talk with third and fourth level meanings, and everyone in the audience would be laughing and getting it, and he could dip highbrow to lowbrow. What? That's fluency. And the thing is that only comes about when we hold ideas and exchange them at a community level, and develop that quorum sensing that we talked about earlier. And so that's what I'm after. So we can fix this. We can do this everywhere. But what are clay, sand, and silt made of? Do you guys know this? This is a good question. Maybe this will be the question for this later on. Hint, hint. All right. Silicon and oxygen mostly. They're all silicates of different fractions and sizes, okay? And when we mineralize things, quite often we're oxidizing them. So they're being dried down to the point of just being mineral. It's wild when you start putting these pieces together and seeing the world in a completely different way, a way that we were never taught in schools, a way that we, there's nowhere on the internet, talking about these things unless you're on my channel. So they're all related to, remember Silicon Valley, silicon microchips, silicates, they can transmit and hold information. So when we look at the soil and realize that there are varying degrees of clear and light travels through the soil, and light is energy. When we look at the soils and we think about information transfer and information storage, and then all the fungi is tying together and inoculating, so the whole thing is eaten by them and embodied by them all the time. So there's a lot that plays out here that's very strong and very interesting. So they're the minerals are the hardware. The software is really the organic matter, and it's actually the battery as well, because that's where the energy is stored. And then the users truly are, the operators truly are the microbes. And we can like talk to the microbes, but we can be the boss, we can do that kind of paradigm. Or we can be, collaborators, but they do the fine work. Their little fingers are they don't have fingers, but they're at the micro level where they can do the work at the scale that it needs to be done and at the rate that it needs to be done. We can't produce it on our own with machines or other things, the compounds and the nutrients in the forms that these microbes do. It's really important to recognize that most modern medicine is grown in giant microbial vats in which we've trained microbes to create very specific things. Streptomyces, which is the second most prominent microbe in our soil, makes penicillin. The majority of the world's penicillin in vats, in factories. Aspergillus niger, black mold, creates citric acid. That's an ingredient in like everything. So when things go bad and they form black mold, yeah. So there's lots of reasons why people are taking control of their health and being like, I don't think I want to eat your food any longer. Thank you. So let's start at the beginning. I know that we've covered so much, but let's start at the beginning of everything. Where does this all begin? Begins with the light, the sun beaming down on the plants and photosynthesis, right? On earth, on land, different from the water, oxygen is vented. Really important to recognize that, so that if you're going to do some aquaculture, we just had aquaculture, and we just had, we covered Veta La Palma's work, the regenerative wetlands. We covered the floating regenerative islands of Dr. Is it Buren? No, it's not Van Buren. Is it not? It's not Van Heusen. Oh my gosh, I'm blanking on his name. Well, Dr. Brian, he's in the 2040 documentary, excellent movie. You can see his work in there. And then Neil Speckman's coastal regeneration work, where he's taking a few hectares and then feeding thousands of people in the poorest countries of the world, giving them jobs, and then setting it up so that they run it themselves. This is the future, healing the world through understanding these simple processes that are at work all the time, passively working for us. Notice how photosynthesis releases that H plus, acidifying and reducing the soil on land. That is happening all the time in healthy plants. And there are some that are survivors in and adapted to those areas that are the opposite, very alkaline, very oxidized, like heather and other things. No, heather's acidic. Sorry, reverse that. But there are things that deal with very alkaline soils. But they're the non-mycorrhizals. They're a small group. They're the weeds. They're successional, which is the beautiful part, because after a certain level of organic matter, the water is held at a high enough level in the soil, and then it's acidic by default. So I can't help it. So even if you're like, I just have weeds, I just can chop and drop, I can't do anything else, you'll get there too, my friend. So the hydrogen cycle is the seat of photosynthesis and pH. Notice how stress plants are releasing hydroxide, but they're also having to release hydroxide to get all the different forms of anions. Cations are only coming to H plus in exchange with H plus, because they bombard the soil particles and the minerals around them to release those. Again, we look right here, those are sugars being made. And when we think about our own diet and they're like, oh, sugar is bad. Oh, sugar is bad. We're talking about monosaccharides, okay? We're talking about monosaccharides, are the sugary treats that we all talk about. Polysaccharides are the medicinal compounds in mushrooms that do not taste sweet, right? Right. Plants are the same way. Polysaccharides are medicinal and strengthening. Monosaccharides open them up and to attack. So they're non-reducing sugars. Reducing means giving you energy in the chemistry language world. So polysaccharides, they're going to give us energy. Monosaccharides they're not going to give us energy. And so you're pathogen bait if you are creating monosaccharides. Simple sugars. This is why we get sick. This is why people have candida overgrowth. All of it revolves around simple versus non-simple sugars. What if the same foods that you are eating, grown regeneratively versus not, have these different sugars? Guess what? This is really happening. Our plants that we're eating that are not truly regenerative are pathogen bait, and because of that, are giving us nitrates and simplified sugars, such that they're not nutritionally feeding us in the same way, such that our guts cannot protect us and give us the nutrition at the same level. This is why biohacking has to go back to the soil and the plants. And if we don't, we'll always miss. We'll always miss the real picture. So these power plants are bringing down energy, feeding the soil life, bringing down sugars. They're doing all these different things, empowering the soil life, creating soil structure, creating the dark carbon-rich soils that we know are healthy soils. And if we don't do that, they get taken away. They get the soil food web cleanup crew comes and digests them, as they should. And this is the thing. We have to realize that this is feedback from nature when we see a plant getting fed upon, getting dying, getting diseased or sick. It's feedback from nature saying, try again. It's not saying stop, not saying you're bad. It's saying try again. And because of regenerative soil, people now have a guide on how to do that, because there was nothing before. And you're like, oh, well, I was taking this course and, I learned about compost from them, but there was no way to actually vet it. And I know that there are microscope people out there and stuff, but none of them are accurate. And that's why I've had to create everything. So do you know plants have a clock, an internal clock? They really need to handle those sugars and then utilize them, because the next day begins and they can't stop. So it's stress signals versus strength. You don't eat a big meal right before bed because it'll give you indigestion. Plants are the same way. They don't have a choice. They're going to continue on the journey with the rising sun. So when you're powered by the ambient environment, you're unable to turn off the flow. And that's why plants get sick. That's why plants get taken out so fast, so quick sometimes, because they can't stop it. They're out of control, and they're moving too fast, and they're just they go off the rails. They hit a wall. They're just they're out of control. So because they're primarily passive organisms, they actually don't signal with their exudates like, oh, I want these microbes or that. It's a shotgun blast. That's, again, another misconception that's been circulated. They're passive organisms, and unless they have internal and external biology helping them, they're vulnerable to attack. And they've evolved with these organisms in place to protect them. So when we remove them, or when we dry down our seeds and store them, we need to bring them back, because otherwise they won't be present. Our dried down seeds, we kill the microbes in order to dry them down, unfortunately. And that's why it's on us to bring them back. Whoa. All right, so what does this all mean? Well, we need to help the plants process and digest their food properly and completely. And how can we do that? Well, we can do that very simply by acknowledging these aspects and making sure they're coherent and working in harmony with each other. And it really is this simple. I know that there's endless complexity in this space. If you look at it at the wrong angle, you can beguile yourself very easily. And if you look at numbers and just end up counting, we're going to count all the bacteria on this slide. Oh, they're moving. Oh dear. It's like trying to count, 50 chickens in like a 3-foot wide barrel, and you're like, they're all moving and milling, and you really can't do that to yourself. So being able to bring it down to this simplicity is actually a functional layer, so that you can take action and make decisions and examine all of these things individually in a way that allows you to make good decisions. So that's really what I've been working on these past several years with the Regenerative Soil Trilogy. So these all work together. They contribute to proper photosynthesis and adding energy. The microbes help them get their nutrients. This is what the soil food web's function is. The nematode is an omnivore. This is a test state amoeba. If you're doing hot compost, you're doing hot compost pretty regularly. You're doing a mother compost, you're going to end up seeing these test state amoebas. They create this shell on the outside of them instead of being the blob, because the constant difference in moisture and pH and heat and redox, the constant change makes them create a shell to protect themselves from that. It selects from testate amoebas, or they create their shell. It's not exactly clear. We're still mapping out how these things adapt and change. So much of the work that is being done now is figuring out which ones are the same exact ones. So we have all these names, and they're actually condensing because they're like, actually, this microbes has 3 of these expressions. It could be filamentous. It could be a cocci, you know, like little spheres, or it could be bacilli, and so it's like little rods. Like literally, this is. I'm thinking of a very specific Norcocades, like microbe that we see in Johnson's soup compost. So it's really important to recognize the fluidity of this space and to be open to that. And that's really something that I've not seen anywhere. And it's put an immense amount of pressure on me to create something that really pushes things forward and opens the door in such a way that allows for deeper exploration and discussion at the community level. You probably heard of this. This is the soil food web, you know, way that plants get nutrition. This is one way that plants get nutrition. It's not the primary way, but this is the whole cakes and cookies metaphor. The reality is a little bit more complicated. Fungi and bacteria, yes, they embody nutrients, and so they need to be released by protozoa and nematodes. But fungi and bacteria are also releasing, stimulating, and triggering plant roots in a variety of different ways. Free living and endosymbiotic are doing this. It's not just like particular types of bacteria, it's all the types. And then the rhizophagy cycle is primary. So before there was nematodes and all these other different things, we had simple bacteria and fungi. And we know this through succession. You simplify everything out in a field, you don't have nematodes and protozoa in there. You have bacteria and then fungi. And then it builds up towards those other things. So for the plants that must be there for that even to be process to begin, they're existing only on the rhizophagy cycle. And so what that is all the simple small microbes, they're farmed at the root tip and then sucked in and then bombarded with oxygen, superoxide. And remember, oxygen rips off the energy. So they're taking the nutrients off, which each nutrient has an energetic charge, which is like an energetic key that allows them to do the cycles within the plant. But what happens is they kill a bunch of the fungi and bacteria coming in, and the ones that survive repopulate inside the root hairs. And without this happening, you don't form root hairs, ever. Never will you form root hairs unless you have the rhizophagy cycle. So we know the rhizophagy cycle is primary because all the mycorrhizal fungi, where they're inoculating the root hairs and all the root tips and all these things, they're hijacking the same highway that the rhizophagy cycle used, and then they're essentially closing it off and shutting it down permanently when they inoculate and cover the root and clad it. And so it's primary. So before mycorrhizal, before, you know, the compost soil food web conception of nutrition, there is the rhizophagy cycle. And endophytes, what happens to them? Oh yeah, this is what it really looks like. The root hair. Do you see the expelled bacteria? Pretty amazing. Oh, I don't even have it in here. Well, I should tell you, the endophytes, they actually release nitrogen in order to survive. And so the plant internally is getting nitrogen fixed by microbes that they're bombarding with superoxide and they're endophytes. All endophytes have to fix nitrogen internally inside plants to live. Otherwise, they can't persist. Completely new information thanks to James F. White on all this. And so I really feel grateful that I'm able to share all that and then verify it and see it. And then you, of course, have the mycorrhizal associations that I was talking about. But what does that look like? It's beautiful. And then again, we have those bacterial associations where they live in the root. This is what they actually look like. And then you might be asking, why nitrogen fixtures? Well, they're tenacious. So they can hold things together, they can cover things, they can protect things. And then the biology isn't a nodule, so they're protected. So that's why you can kind of go into sand with legumes. That's why people recommend, you know, in the middle of the desert, get those desert legumes going, because they're the thing that are going to hold the nitrogen and release the nitrogen in the soil over time. And then there are also key ingredients in our composts. And this is what an actual, nodule looks like inside. There are these little pockets. And they promote themselves to a certain point. And then when it gets really, really tight and they've processed as much nitrogen as they can inside there, then the nitrogen begins to leak out back up into the plant. So we talked about this picture, the plant anatomy. There's also the leaf surface. So there's the trichomes. All plants have hairs on them that are called trichomes. And inside them are nitrogen-fixing bacterial communities and fungal communities. And so we need to make sure that we are doing everything we can to provide the right biology for these spaces. And some of these things are still being mapped up. In the cannabis world, there's a realization finally hitting that terpenes are conversations between microbes. This is one of the things that James White and I figured out while we were talking about all this ages ago. And it's those flavors, smells, and tastes that microbes are creating, the plant secondary metabolites that in terms of like cannabis or like frankincense or some other medicinal that relies upon terpenes or smell or taste or all of that relies upon microbes. And so it's really incredible. It's really powerful, and it's new territory that many people are just getting into and exploring. So fertile. So biofertilizers, biostimulants, biocontrol, buffers, and filters. Soil biology has the greatest effect on soil pH and EH and nutrition. This is really important to recognize and understand. Without our internal and external biological support systems, we would not be able to access nutrition or process our pH and EH reactions. All right. I was just checking to make sure everything's working over there. A sterile field lacks the fertility and life that is required to process things. A sterile body lacks the fertility and life for health. You may take probiotics and prebiotics and etc., but what about your immediate environment? I know like Lead Safe Mama is like destroying her house trying to get rid of all the lead in it. What are we doing in the soil, the food, the air? Because we literally can create, giant hyperbaric chambers essentially by just crowding our house with light and surrounding our house with a food forest and orchards and everything. We can do this. We are not isolated beings. This is one of the most important things to realize is 60% of what touches our skin goes in, Heart Math Institute. You guys heard of these guys? You can feel my heart when we're in the same room. There's a field that our heart puts out, like a 10-foot radius. Some people it's bigger, some people it's smaller, but we resonate with each other and we feel different when we're in the same space together than we do digitally. You can feel it. And as I said, 60% of what touches our skin goes in. Something Antoinette Marquez always says, what if we stacked our functions a little bit? What if we created like a cold plunge that was a natural swimming pool that was also a mineral and biological dip that's tailored to us? And you're like, what are you talking about, Matt? Lactobacillus lab is actually on our skin. So that idea of like the biological dip is not far-fetched. I don't agree with doing compost tea soaking. It has me really worried actually because of a lot of things. But we can tailor these things. A mineral dip is what people are doing in biohacking already. I've got, they're not in this room, but I've got these little bags of seaweed that I put in bathtubs for doing mineral soaks. This is something, I mean, thalassotherapy, baths, spas, all these things have a long history of therapeutic value. And we could be creating that for ourselves on our sites, surrounding it with plants. So we're grounding ourselves in the water. We're breathing fresh air surrounded by plants. If it's deep enough, man, it'll stay cold when few other things are cold. You can cycle and clean the water with plants and sand filters and biochar filters and a UV light filter. You can, make it mineral and biologically rich. This is all possible. What else? We can design our habitats to grow almost anything now. Why not your health? Maybe what our ancestors actually were focused on. When we look at the earliest humans in the Amazon creating thousands of forest islands as they tamed wild plants, right? This is Science Daily here. We can't help but think like, why, were they doing this? Was it just to conquer nature? Or was there something more to this? Was it natural what they were doing? The Aborigines certainly did it in Australia. Permaculture is certainly seeking to do it as well. And everyone needs to eat as locally as possible. Everyone needs to be in this loop, this environmental connection. We need to make blue zones everywhere. So we need to eat locally as much as possible. And everyone can participate in shaping their surroundings regeneratively. Remember those blue zones? There's a microbiological aspect to these blue zones. And it's because there's a limited number of interactions. There's people who are local. Yeah, there's visitors, but there's a repetitive, predictable series of changes and interactions. This leads to a well-defined feedback loop microbiologically. The local food, the local biome, the local rhythm, the local culture, and the local soil. I misspelled rhythm. It all is based on the local soil. And right now, 12 million hectares of land is lost to desertification a year. Desertification is the death of soil, and it's the loss of the topsoil. I'm not talking on this kind. Natural is natural, right? But when we mismanage our habitats in farms and in national forests, we lose our soil. And you guys know the story. We're seeing all these soils run away and kill our rivers, streams, our deltas. And everywhere this type of farming has been practiced, there's been desertification and eutrophication. And despite people trying to blame everything on cars and CO2, it's actually this that's causing immense amounts of damage, maybe most of the damage. And we really, there's other factors too. There's all the other pollutants that are released by all of the burning and all of the processing and all of the, the accidents, and you know what I mean? There's all that whole side of it too. But which also they're ignoring in favor of CO2, you know what I mean? So everywhere we practice this, we cause desertification and eutrophication. And we can do better with life, with biology. Check out the Albedo Project, okay? This is Saudi Arabia. This is my friend, Neil Speckman. He's a guy in Utah. He's worked in some of the craziest places on earth, Eritrea. I mean, he just goes anywhere. And this is the same spot 3 years later. And now it's completely covered. It's unbelievably gorgeous. That that growth gets chest and head height high. It was earthworks, perennials, nitrogen fixtures, and rainwater. And they went 3 years without any rain. So you know what's possible. And we can speed nature up. For every 1% increase in soil organic matter, we're able to hold 20,000 gallons of plant available water more in that first foot of land per acre. Now, depending on your arrangement of minerals and biochar and clay concentration, that is going to wobble that number. But this is coming from these no-till pioneers that know, they've actually done it. They've increased 10% in 12 years or soil organic matter. But what can we expect for ourselves? Well, with these methods, with the things I'm talking about, with the insights I'm having, and with all the people that are practicing this, we're seeing pest infection and virus and disease immunity. Even when there's the locusts attacking in Africa, you're having these farms in the middle, surrounded by everyone being destroyed, and their farms untouched, because those things, all of those things, infection, pest, they all feed on simple sugars and nitrates. So complete proteins and long chain sugars, polysaccharides, problem solved overnight. We've seen this in America. We've seen this all over the world with regenerative, with natural farming. It's been proven out. Plants and animals can develop immunity to everything if they have the right inputs, minerals, and biology. High nutrient density. You're going to see plants that are more nutrient dense than any of your other plants in your experience. And then they're going to arrive faster. They're going to be bigger. They're going to be brighter. They're going to smell greater. They're going to taste better. And they're going to come at a higher yield. So you're going to get more. You're going to get it faster. And it's going to smell and taste like nothing you've had before. And because of all of this, you're going to be able to, massively decrease your fertilizer inputs. And you're like, Matt, I'm already just doing, composted manures and all of that and doing cover crops. Great. That will improve those, and you'll be able to diversify and do less of that and do more growing. Less amending, less cover crops. You can start mixing in with your cover crops other things that are of value. And so it becomes less work over time. You earn more, you grow more, you work less. If you want to learn more, ask me. We're going to have a live Q&A here in just a second. And join us next week. Same day, same time, next Wednesday. And we will delve deeper into this subject matter of soil and the importance of it. And we'll be able to learn more. If you want to learn more in the interim, check out all the things I'm doing. See awesome pictures, watch more videos, visit regenerativesoilscience.com. That's a lead link. So just type that into your thing, and it'll change into my website, my home site. It's just a longer like list of letters and such. So this is just easier. Thank you for being here. It's book giveaway time, ladies and gentlemen. I hope that you have been enjoying yourself. Thank you for being here. Woo! It was a whirlwind of information. I appreciate you all. All right. So let me just grab this and check on. All right. So YouTube is, let me just see where they're at. All right. Sweet. YouTube's just behind. Thank you all for being here. I see you guys in YouTube. I see you guys in Zoom. I appreciate you all being here. Okay. And I understand how difficult this is going to be. We'll do one book giveaway to start with, and we'll do it on the Zoom side, and then we'll do another giveaway on the YouTube side, and then we'll do another giveaway here on the Zoom side. So No matter where you are, you'll be reached. And then let's dive into some questions in the mix of that. All right. So if you don't have this book, holy cow, oh man, this has all the soil cycles, all the mineral soil cycles for the first time ever gathered in one place. And for a lot of them, the first time they've ever been made visual. You'll find graduate school texts where they're like the boxes and then, or just text for 3 pages. Originally, I wrote out all the cycles in words because of this. And then I was like, Matt, this is dumb. Make them visual. And then like the book went from like 400 pages to 200. Literally, but it took 3 months. So this is an incredible book. Let me show you what I'm talking about. So like, here's the copper cycle. And you're like, what do I do when, chlorine is toxic? What do I do when it's deficient? What are the sources and forms of that? What about the manganese cycle? The manganese cycle, you need manganese to actually fix nitrogen, right? So these are the kind of things that are in this book. And then you're like, okay, well, what are the actual availability of these nutrients? Well, that's what these are. These have never been published in a book before. They're published in the literature for scientists, like in studies and papers, but no one ever put them into books for us to actually use. And so let's say you just have a pH meter and you're like, and you've got your soil test and you're like, man, I don't get it. I have this in an abundance, but it's just not showing up. Let me show you a specific one. Look at cobalt with me. See that? Cobalt's essential to all animals in life. So B12, remember the biological vitamins we talked about at the beginning? Biological metabolism. So all cellular metabolism relies upon B12, which is centerpiece of B12 is cobalt, right? Cobalt. So cobalt, look at the pH, pH 7. So unless you have acidic areas, cobalt's not bioavailable. So and yes, cobalt is released into that form. It's important to have the biology there to do the work. But also, when we're aware of these things, that's what I wanted to show with that. That's what I wanted to show is that you may have something where the EH is playing a game with you. Like look at nitrogen. You're like, I have nitrogen. I don't understand why I don't have the right form. It could be redox. Let me show you what I mean by that. Look at that. So you're like, oh, well, if I'm pH 9 or below, I should have this. But if you are oxidized, so if your soil is dry and over-tilled, you're going to be up here in nitrate land. We're going to gas off in between. Do you guys notice that? See the oxygen? Yeah. So you can use this to troubleshoot and figure things out in a way that's never been possible before. Because no one ever gathered these elements together. I had to figure it all out myself. This is my gift to you. This book this is considered my best book. Regenerative soil microscopy, the next in the trilogy, is coming out soon, so you guys can, we can see what people see about that, but this is to date, my best book. So I'm going to ask a question. Everyone get ready on the Zoom. If you aren't on the chat yet, click down below, click on the chat, get your hands on the keyboard. Here we go. All right. So the question is, clay, sand, and silt, what kind of minerals are they? Excellent, excellent, excellent. You know what? Rob said silicone and oxygen. It's not silicone. They're silicates. Michael Hausch, you nailed it. Michael's a student of mine. Good job, Michael. But Rob was first to answer. He had it. You know what I mean? It's not silicone, right? But I had Silicon Valley in there. So, but I feel like Rob would benefit from this. You guys feel like that too? Let's give this to Rob. Okay. Thank you, Rob, for participating. Rob, I'm going to give you my email right now. And I need you to email me your information so that I can ship this to you. Oh, no, I sent it to Tyler. That was not correct. This is so funny. Zoom like automates sometimes the two, so that it just like sends it to one person. And you're like, what are you doing, Zoom? No. All right, here we go. That's my email. All the winners, email me, and I will with your address and shipping information, and I will send you the books. So congratulations, Rob. Way to go. All right, let's do some questions and then we'll circle back. All right, so I think the best thing to do is I'm going to start on Zoom and I'm going to scan for questions. It's probably best that you ask questions at the end with a big bold, like all caps question, and then ask your question so I can find it easier. I don't want to waste anyone's time. Okay, good. Someone says I can't hear, and then everyone's like, I can hear. Okay, good. If we had gone that whole time, oh man. Have you ever done float chambers for meditation? No, that's wild. I've heard about that. There's that Simpsons episode, right? But yeah, no, yeah, chose for dinner would be amazing. I'm so honored that that's actually on the table. Great to see so many people excited. Where in Iowa, there's a podcast on it on Regenerative Future with Matt Powers. That if you look food forest regenerative future, those keywords on my YouTube, it'll pull it up in the videos and you can find out. Yes. Does neem oil destroy soil biology? I haven't tested neem oil. My experience with a lot of this stuff is it's much more selective. Like a lot of these natural things that work pretty well, not like caustic. They're not like killing everything, right? Like that's, really well according to the thing, destroying. We're talking about destruction, right? So we don't really want any of that, right? And so my thinking is that neem oil is actually probably a selective process, not a destructive process. So it's going to occupy the area and then allow certain things to promote. But yeah, no, I'd love to test that. That's a great thing. Will this be live for replay? It's on YouTube. All right. What is the thoughts on microgreens as food source, vitamin additive for digestion, microgreen meal, compost tea, and microgreens added to our animal feed? I think microgreens are great. I mean, in nature, we're always eating what's like really young. I mean, if you've ever raised chickens, you know that you're like not letting them grow up if you're growing them for food. There's a cutoff point where the animal goes from growth to maintenance, and you want to consume it while it's in growth. And the microbes is the same way. I mean, plants is the same way. You want them when they're tender and digestible, not woody and dried out, right? And so there's a real timing to so many of these things. And so So yeah, no, microgreens are great, highly nutritious. What was the name of the Science Daily article he mentioned? You have to just scan through the replay. It's I can't pull it up right now. I can sort of see it. I'd have to take a few deep, long breaths. Reoxygenate the brain. It's about how synthetic nitrogen destroys soil carbon. It was the myth. It was called the myth of nitrogen fertilizer. The myth of nitrogen fertilizer, and then the other keywords on it are carbon or soil organic matter. Those two with Science Daily will allow you to find it. That's actually, you guys get to see how my memory works. I grab onto keywords and triangulate. That's how I find everything. Yes, great to see so many people here. Excellent, excellent questions. Oh, here we go. Have you worked with frequency and nutrients in soil? I have not measured frequencies in soil, but I'm measuring millivolts. Be interesting to think about how we would measure the frequency and what we would be looking at. Very interesting question. Thank you for giving me that to think on. I will think on that. What is your opinion of I live in a mining area, arsenic remediation 10-year project going on, bioremediation ideas for my property backyard. Arsenic, let's look at arsenic in the book, because I'm pretty sure it's going to be like fish bone meal. Let's go to the soil remediation section in the book. And let's go to arsenic. So we need to oxidize the arsenic with bacteria like alkalogens, Pseudomonas. Pseudomonas is in like everything, like compost-wise. And we can reduce it with some of the same ones, except micrococcus is also involved. So you can inoculate the soil with sawdust, inoculate it with shaggy mane, Coprinus comatus to sequester it. You can plant hyperaccumulating nitrogen-fixing crops inoculated with Rhizobium. We talked about Rhizobia earlier. It's the nitrogen-fixing bacteria in the nodules, and Trichoderma. These help plants hyperaccumulate the arsenic, and then you can take the plants off the field and separate them, and you're pulling out, wicking out essentially the arsenic. And then plant colonial bentgrass, rice, or white lupin to extract, depending on where you are, what plants work best. And you can plant trees, Douglas fir and poplar, depending on your site and the systems that you're doing. So you could do those things for that in specific. And the reality is, it's about how much. Because if you have enough vigorous biology, if you have enough spaces on the minerals and biochar and organic matter to bond and bind up the arsenic, you will be able to see those numbers go down in your plants being sucked up. For some tests and for some forms, they'll still be there when you test it, mineral test, and they won't be in the plants because you've got that buffering. And then there's a furthering of all this where you're actually removing it and it's lessening. So you're going to have a combination of those things happen, especially if you're going bioremediation. You're going to have things that are helping buffer, you know, things that are filtering, you're going to have things that are embodying. The problem with embodying is that when things get hard, when things get stressed, you have those things be released. So you're like, oh, I turned all the lead into pyromorphite crystals. Okay, what about the phosphorus that the fungi mines out of the pyromorphite crystal? Lead is suddenly again loose, right? So we have to think about these things strategically and then monitor them, because changes can happen, and they often do. And so I wish there was a magic wand, or a golden method, that would fix everything, guaranteed. Just do 5 of this, but it's never the case. It's always that we have to test, we have to look, and quite often we have to look a variety of different ways and perspectives to even see the thing that we're trying to see. Any information on electroculture or gardening with copper? Yeah, so there's a few different things with that. You're inevitably gonna have the copper come off, right? Because as it's exchanging, and as it's doing its thing, it's going to be releasing copper into the soil as it starts breaking down and oxidizing and turning green and all that, right? The transmission of heat is a form of energy, infrared. That's going to make plants show up earlier and grow faster in the initial stages of growth. And so people are like, wow, I'm seeing my plant that has an iron rod or copper rod sitting in the sunlight grow first. And I'm kind of like, I want to put a bunch of just conducting rods that are just heat thermal rods down. And maybe even put like a barrier between them, that's an electrical barrier, like rubber or something, and show that the heat has an effect, because it does. And then electroculture is the idea that we can raise the energy levels to get more nutrients. Who else had that idea? Chemical ag. They're raising their EC with salts. And then it gets to a certain point where it's too much, but up until that point, it gets more and more nutrient dense and more nutrient rich. And so you have this idea that, especially when they're raising the EC high, their electrical conductivity, they're stripping the nutrients out faster. So this is essentially what they've done in so many cases. And so I worry about that, following that as a paradigm with electroculture, especially when the plants themselves are supposed to be the ones conducting the energy. And keeping in mind, I have nothing against thermal, thermal radiation, infrared, and doing heat sinks and all that, permaculture awesomeness, making microclimates. I love all that. But we have to keep all those things in mind when we're talking about things. You want to create a superpowered grounding station. What would you do with the plant's soil life? I would create regenerative soil. The more living the soil is, the more reduced it is, the more energy it has to ground you. Have you ever, okay. Have you noticed any severe biological spore cyst loss from IMO 1, IMO 2? No. In fact, the IMO 1 and 2 is just filled with spores. So Brian says lime calcium carbonate effectively binds arsenate. But doesn't that just lock up everything else too? Because that's lime calcium carbonate. You're just locking things up. And that's the thing, is we have to be really careful. I mean, in America, we have all this, most of our water we're getting from wells. And so we have this hard water, this alkaline water, and we just combine it with everything we're doing and we lock it all up. And so we have to be really aware of the nutrients that we're working with. I have a feeling Brian is working in very mineral acidic soils, so he can do things like that. Is someone practicing what you teach a regenerative soil grower? I have many people practicing what I teach. People doubling their yield following just what's in my book. What words or phrases would you describe a grower who is using your teaching in their garden? Someone practicing regenerative soil techniques. You're so welcome. Property 400 yards from open septic, sanitation, lagoon, a deal breaker. Open sanitation. Yeah, so this is the thing. The gassing off of the bad things means that it's literally in the air. So there's air pollution caused by biological remediation of contaminated water and sewage treatment plants. So you'll see in my book, you're like, oh, cool. These water plants are going to like take these things out. And then you read and you're like, oh, they're aerosolizing them. Oh, dear. Right. So we have to keep all these things in mind. Can I introduce purple non-sulfur bacteria to a batch of EM that I brewed using EM1 as a starter by using fresh worm castings? Yeah, but at what rate? You know what I mean? Like at what rate? There is Pseudomonas in there, but is there Rhodopseudomonas? And is it at the rates that you want? So everyone says there's Pseudomonas in worm digestion. All the compost that I'm finding Rhodopseudomonas palustris in small amounts. In some, there's larger amounts in some of them. But unless you're doing a culture of Rhodopseudomonas palustris, I worry that you're not going to get the effective rate. This is the other thing that people so often miss. It's like sleight of hand that people are doing. They're talking about microbes like in this general sense and not the efficacious levels of those microbes. So we really need to be more particular about which microbes, how much of those microbes. Rice mold that you showed in the IMO collection can survive boiling or steaming. The spores for so many things can go into space and come back. So the hyphae, no, you would cook the hyphae. The spores sometimes are activated by heat. And then the lab is the one I was talking about. That's stimulated. That's bacterial. The fungi, when it's hyphal expression, will break down. But then the spores can resporulate, and I have, tons of evidence of that. Excellent question. Sweet, Barbara. I love your grounding studio. Have you ever analyzed your scientific approach in symbiosis with in relation into biodynamic planting, harvesting, and composting? Of course. Yeah. Yeah, no, I've been studying biodynamic processes for over 15 years. I read all of, the original Rudolf Steiner works. I mean, even the kooky racist stuff. I read it all. He's a product of his time. He's a product of Germany of his time. And so there's a lot of funky, weird stuff in there. And he collected, what he did was he collected all of the practices that he could find that were dying off and then try to find a common thread throughout them. Very similar to what most of us are doing as we try to study and understand the world around us. We collect things and align them and find the common thread. He did that with folk farming and natural farming in Europe, right as chemical farming and machine-based farming arrived. So Rudolf Steiner is essentially like a folklore farmer, like a historical archiver in many ways. And then he went further and started saying, well, this means this, and then these connect, and then we should do this, So yeah, no, I would love to check out more of his stuff, but like in action and in practice. I have someone locally who does blueberries that I'm supposed to visit in May to check out their soils here in Texas that they're doing biodynamic. But yeah, no, I definitely have examined in depth Rudolf Steiner's approach, and it's really important to look at all these things through the lenses of what we can actually test and see and know. Thank you for ordering the book. Excellent. All right. Will you be bringing them Ericoid, Matt? Oh yeah, I have Ericoid. I think it's in the kitchen now. No, it's right there. Hold on. Yeah, I got it. Here, Blue. It's good stuff. All right, everyone. Thank you for being here. I'm going to hop over now to the YouTube to answer some questions over there. All right, guys. Hey, YouTube. I'm going to scan upward and find some of your questions. Here we go. Thank you. Thank you all for being here. Can you send me your yoga routine, Matt? You know what, Shannon? I am slightly like embarrassed and afraid. It really is like soda, diet soda of yoga. It is not, and you know, I know this because Antoinette like schooled me a few years ago. She was like, "Oh, you do yoga? Let's do yoga together." And then she goes and like is like 10 times stronger than me. And I was like, "Oh." She's like, "You're stretchy, but you're not strong." And I was like, "Huh." I lift weights now, and so I'm getting stronger steadily. But holy cow, I am embarrassed about how weak my yoga is compared to what they do. I mean, she's like on one hand upside down, like doing push-ups, and she's like, "Can you breathe like this?" And I'm like, "Okay, all right." So I'm not there quite yet. Maybe someday I'll learn a better yoga, and then I'll reveal. The funny thing is, the woman who taught me that yoga 20 years later, the woman in the video, I know, she's like a fan of mine now, of all things. Bizarre. But it's literally like a yoga CD, like a cheesy yoga CD from 25 years ago. So we'll leave it at that. Great to see you all here. So many names I know, so many people I recognize. It is so nice to see you all. Shooting Soils, answering some questions in here. Good stuff. He's a student of mine. What are the thoughts on Byrosprexum and Mirimichi Green? Yeah, who that is? Mirimichi. What a name. I feel like that could be a character in a Brandon Sanderson book. Oh my gosh. From an alien world. Excellent, excellent. What is the easiest way to use JMS on the lawn? I would just feed it in. I got this awesome tank thing that actually sips off of this tank and passively feeds it in through my garden hose. So I would be taking my JMS, filtering it so that it doesn't clog anything up, and then putting it into there, and then closing it up, and then turning on my sprinkler and doing it in style. So that's what I would do. Does Black-Lemon Blue nuke your gut microbiome? No, actually. Remember, caveat here, not a doctor, not making any recommendations. Blue methylene is one of those things that is a metabolic drug that is absolutely amazing. But because they can't make any money off of it, it's like suppressed at a very, very high level. So it selectively attacks sick cells and leaves all the healthy cells alone. This is why you could be drinking a ton of it, and then your pee will be normal color for a period of time, because it's the dyes attaching and bonding to all the sick cells inside you. And you're not peeing it out because it's inside you. It's kind of crazy. You could be using it on your body and then washing it off, and then the parts that stick blue, those are sick. I know someone who does, Antoinette, does blue methylene soaks. She comes out like a Smurf, and the parts that are sick, it sticks to, and the other parts wash off. Yeah, pretty amazing. So how do you keep a healthy gut while taking that? Yeah, no, it's not a nuking. Blue methylene's not a nuking. And again, like I said, I'm not a doctor. I'm not recommending it, not prescribing it. But biohacking is definitely part of that. I got a transfer pump brew and a 10-gallon. Let me look for a question. And it's really important to understand, if you're taking blue methylene, that you can cause a serotonin storm if you take other things that mess with your serotonin. So like people, I know there's forums online where people are taking blue methylene and then they took something that, like for example, the person in the forum, you could probably find this forum, took mushrooms of a certain type, and it caused a serotonin spike, and then they were sensitive to light for months. You gotta be careful. All right. Looking for questions. Great to see so many people here. Looking for final questions now. We're near the end. Thank you all for being here. How should I remedy high acid soils? Because I get too much buttercup growing. I'm pretty sure it's the high organic matter, and soils hold lots of water. Shannon, I would get a broad fork just to start with, because acidity is linked to the higher pH, power of hydrogen. It's linked to moisture, and you're right, thinking it's loads of water. So biochar actually in this instance will, I know it'll hold water, but it also will help increase drainage. It helps us get that Goldilocks range of holding water. So I would mix in biochar. I would broad fork it, and also do some hot compost. Hot compost is always going to be alkaline, and it's always going to be more oxidized, because you're turning it with air and it's burning. You know what I mean? And so you end up having nitrates and all the things that are oxidized and alkaline in there. And that's why people nowadays with Lane compost style composting are letting it sit for months on end, doing basically a static compost finish. Which of your books would you recommend for a survivalist to keep on hand? Excellent question. I would say two books, actually. It would be The Regenerative Soil, because that allows you to understand nutrition and understand the actual physics and chemistry and biological processes of all the world around us. So you'll be able to unlock and create medicines of all sorts, and it opens an entirely different door. So that's really useful. But Permaculture Student 2, the purple book, is 400 pages of advanced permaculture design. There's no other book like it. But maybe get Regenerative Soil, because you can get Permaculture Student 2 as an ebook for free off my website. And the audiobook for it is on this YouTube. So that's my gift to you, T Fitty. But I would get Regenerative Soil, because it'll change the way you think about the world. You'll see everything completely differently. You'll see things energetically. You'll see things biologically. You'll see things along cycles. Are beneficial nematodes an option for deworming chickens? That's an interesting question. I don't think so, because we're trying to remove worms, and they don't normally have nematodes in them. Matt, what microscope from AM scope would you recommend? I don't really recommend AM scopes, just so you know. I recommend L&W scientific scopes. But 400 to 1,000, that's correct. LED compound microscope, that's great. You got a digital camera, that's great. You'll be able to do all the bright field work, and you can get a dark field adapter for that. If you can't do epifluorescence, you won't be able to just like flip the switch and be like, oh, that's plastic. You'd be like, I think that might be, I can't tell. You flip the switch, it's instant. You're like, oh, that's plastic. And then it develops your eye, and then you can start recognizing things more readily and be like, that's plastic, dude. And I got to do that with Oliver. Oliver and I will be working. I'll be like, dude, that's plastic. And they'll be like, really? I'm like, so yeah, without the epifluorescence lens, you're gonna miss things, just so you know. And then doing viability tests. I mean, if you're just doing bacterial counts, even hip shot, bacterial counts with FDA or something like that, you're gonna get all your counts screwed up. There's a better way to do all of that. It's a combination of epifluorescence and another biological stain, one that actually bonds in a different way than a fluorescence diacetate would. Will there be an opportunity to do an internship at your new base? Thanks, Marcus. I can imagine you need some help. Learning from you, and the practice would be definitely be great. I will probably have sites that I'll do that, but for now, I'm just keeping it just for the family, and it's just, yeah, I have only a few more years left with my boys before they're men. So we're just focused on family for now. In the future, I'll probably have more people on site and be more public and stuff, and set it up so that well, on this site we're probably going to move off the site at a certain point, and then we'll do stuff here at this site with people, and I'll do internships and stuff then maybe. But until then, I'm just focused on my family and keeping things small. Thank you, though. Compost is alkaline when hot. Hot composting, the act of hot composting, is oxidative. And so it's going to always be ripping things apart and making it more alkaline. And that's why when you test compost, I mean, I'm sure you've tested compost, you see that it's just so high in phosphorus, it'll inhibit mycorrhizal fungi, and it's so high in nitrates that if we're using it at the wrong time, will inhibit reproductive growth. So it's really important to understand what we're working with when it comes to hot compost. I mean, even Johnson Sioux, you're seeing instances where the phosphorus is incredibly high. And that's going to favor certain kinds of fungi, no doubt. But are those the fungi we want? So, oh my gosh. So it's really, really vital that we like keep our thinking caps on. We don't think of fungi as just fungi. Fungi is saprophytes. There's mycorrhizal fungi. There's endophytic fungi. There's pathogenic fungi. And so seeing them all individually and examining it from that perspective, I think is like really incredibly important. What about over 20 hectares? Oh yeah. If you're doing it with machines, well, you can set it up so you're ripping. You can set it up so you're injecting as you're ripping, and you can set it up so you're injecting biochar rich compost as you're ripping. So that's what I would do. And if you're like, oh, well, I can only do this type of machine and it's not very sophisticated, I'm limited budget. Well, then you go on contour in strips and you till lightly, potentially deeply, depending on your situation, on contour with those amendments. And then you immediately plant a new cover crop into those tilled areas so that they're reductive plants. So the reducers that will acidify. Oh, no. You're alkaline. Sorry. Backwards. You want to take it out of the acidic. So you would plant non-mycorrhizals. So non-reducing. So talking amaranth, talking sushar, talking echinopodia, all the Chenopodia family. So those things are easy, cheap cover crops. They grow like crazy. You're doing a hot compost mixed with biochar, ripping it in, or even tilling it in a strip on contour, planting those. And because it's on contour, you have this rhizospheric filtration process happening where the water is traveling down the hill through those and leaking into the next section. And as that happens, you get more transference of those not personality, of those characteristics that are desirable. Compost can be acidic, it can be alkaline, it can be neutral, it can be fungal, it can be bacterial, it can be all sorts of things. But hot compost, if you just do the old Elaine Ingham hot composting or the Berkeley method, that's high in nitrates. I mean, it's just it's not reduced, it's alkaline and it's oxidized. We're using oxygen to break it down, so it would have to be oxidized. All the heat is coming from the liberation of energy. That's what the oxidation is, the loss of energy. So these fundamental things were never rolled into the mainstream understanding of compost or of soil. And so we end up creating this situation, terrible confusion, where people don't understand the way that things actually work. Mickey is asking about inoculating plants using natives. So what I was talking about was with James White, the Iroquois nation used to take cousins to corn, in other words, grass plants, native grasses, and they would soak their roots in simmering water overnight, waking up the lactobacillus, and then use that to inoculate and soak their corn seeds. So it's that transference of biology from the natives to our annuals that we were talking about in that instance. And we can do that with a lot of different things. You can be crushing the nodules of your nitrogen fixers and inoculating the next generation of legumes before you're planting them. Matt, I'm building a fabric raised bed for the indoor. What should I put underneath the fabric pot? Sand. Well, you're going to want to put something that's going to capture the moisture and not let it get on your floor into your house. If you do sand and you have to do a container. So as the sand combines with water, you're aware of this and it doesn't trick you and then get water everywhere. But yeah, sand can be really great because you don't want it sitting on its feet in water. You could do gravel, you could do sand, but make sure that it's all contained. It's all you don't want to have things get out and have the house be ruined. All right. Very, very good. Excellent. 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 Thank you all for being here. All right. Well, it has been 2 hours. I hope that you all join me next week, same time, new topic, but same day, same time next week. And we'll delve deep and we'll have another live Q&A and giveaway. And speaking of giveaways, we still have 2 more giveaways to do, don't we? All right. So this book is for our friends over here on YouTube. All right, guys, everyone ready on YouTube? Fingers on the keyboard, ready? What does phosphorus inhibit? If you've got compost with really high phosphorus that you're adding, what does it inhibit? This is your moment. You're going to get a book, Unstoppable Enthusiasm. This is my secret. People ask about my routine. This is my routine. Zoom. Oh, there's a delay. That's right. There's like a huge delay in Zoom. So I'm going to figure this out in a second. We're going to see who it is, but I'm going to keep going. All right. So phosphorus inhibits. There it is. It doesn't inhibit all fungi. It inhibits AMF fungi. Marcus Seltzer, you are correct. Marcus, email me at matt@thepermaculturestudent.com. You know me. You got my email. He's a long-term supporter of my work and student of mine. Marcus, I'm so excited to send this to you. This is one of those books. I don't know if you have or not, but this is one of the special books. So excellent, excellent. It's arbuscular mycorrhizal fungi. It's mycorrhizal fungi, but not all fungi. So excellent, excellent work, Marcus. I'm going to pop over here to our Zoom attendees. And this book took 5 years, well, over 5 years to write. This is with a Disney, Warner Brothers, Netflix, and Cartoon Network artist. And this was a collaborative effort. I wrote the words and she drew the pictures. And this is about a food forest in the middle of the Moroccan desert, similar to the Jeff Lawton food. You remember Jeff Lawton found that food forest, right? I had like a dream about what it would be like if 2 brothers, I have 2 boys, remember, found this food forest because they got separated from their parents because they were arguing. Right. Lessons. And there's lions and the older brother makes fire and saves the day. Like, this is good stuff for kids. And then the parents find them and then explain how their ancestors, sorry, I'm just flashing it, how their ancestors did this work and how they, with seeds, can participate in this work. So it's a lesson about food forests. It's a great fun one for kids. It's a lesson about oases and about how we can green the deserts of the world. So it's this book could be yours. So that's the final giveaway for today. We're going to have giveaways next week. I hope that you join us next week. I'll be promoting, I'll be emailing it out. So keep an eye out for it. I appreciate you all. Thank you so much for being here. The final question is, oh, that's a hard one. I don't know if I'll do that one. No, let's do that one. Okay. Why is it not useful to just say, I have soil fungi? I know this is like a sentence, but why is it not useful to just categorize all fungi as fungi when it comes to soil fungi? I know this is a challenging one. This is like one of the most important lessons that I have to share. What's the reason behind that? You guys, it's okay if you don't know the answer. That just means that I needed to teach it better. We need many good fungi. That's right. And if we just look at one, we'll be tricked. Barbara, I am so grateful that you're here. Barbara, you guys has been coming to these lives for so long. Oh, so excited, Barbara, to send you this. Ah, this is so nice. So Barbara's absolutely right. We need a diversity of fungi. And if we just think about just fungi in general, we're going to be tricking ourselves and doing a disservice to our plants and to our soils. All right. So Barbara, message me at matt@thepermaculturestudent.com. Yeah, matt@thepermaculturestudent.com. And we're already in communication on email. So just message me. Because I've got your address probably saved in the address book, but I just want to make sure that it's the same address. Thank you all for being here. I'm Matt Powers. Grow abundantly, learn daily, and live regeneratively. And I will see you all soon. Next week, we're having 2 webinars, so it's going to get crazy. So stay tuned. I'll see you soon and get ready for more giveaways. Have a great week, everyone.